All right, welcome to Research Methods. This is a video lecture for Wednesday, January 18th, day 3 of Research Methods. All right, so last week, we talked about 5 steps of the scientific method. We talked about hypothesizing, operationalizing, choosing which method you want to use. So now we're on to the 4th step, which is evaluating the study once you've already done it, then on to revising or replicating, and then we'll wrap up today with talking about research ethics. All right, so at this point in the research process, when you've already completed the study and you have chosen a method, right, you've operationalized, you've hypothesized, now your study's done, it's over, and your next step then is to evaluate the research. And to do this, you ask a couple of main questions at this stage. You ask, how reliable is the study? How valid is it? How confident can we be in the findings? And what do the results actually tell us about people? So with that in mind, the first thing we're going to talk about today is reliability. So reliability asks the question of, does some measure that you're using consistently give you the same results? So reliability in particular, the kind we're going to talk about today is about measures that you're using in a study. So for example, if you take an IQ test 4 times over the course of the year, you should get pretty much the same results or pretty close to the same results every time you take it. So a given measure that you're using, it should give you the same or similar results each time that you're using it here. So importantly, some variability is expected in measures that you're using in psychological research because we're dealing with people and people can be pretty complicated, right? It's not the same thing as, measuring a quantity of a chemical where you should get exactly the same measurement every time you do it. With people, there's always some variability involved in the process. So IQ test, for example, with this example, doesn't have to be quite as exact, but it had better be pretty close. So if an IQ test gives me a score of 80 at time 1 when I take it, 150 at time 2, 112 at time 3, it's nowhere near reliable. It's all over the place with the scores that it's giving you. Versus if you take an IQ test, 3 different times during the year, and it gives you scores of 102, 105, and 101, that's pretty reliable. It's all in the same range, seems to be pretty accurate, right? So it doesn't have to be exactly the same. That may or may not be very practical, but it had better be pretty close, in which case, if it is pretty close, then you have a reliable measure. If you don't, it's not reliable, and that skews off your entire, your entire interpretation of what the results mean. All right, that's really. The other question we ask at this stage is about validity. This is how well was the study carried out? So does the study accurately capture the variables we're trying to measure? Is the effect we found real? Questions like that. And there are 4 different types of validity that we pay attention to when we're evaluating a study that's already been completed. Statistical validity, construct validity, internal validity, and external validity. And we'll talk through these one at a time. All right, so first up is statistical validity, and here we're asking, is the effect due to chance, or is it statistically significant? So with statistical validity, what you're doing is using math to determine whether the results you got in the study were a fluke or whether they were a real effect. Now, statistical significance, you've probably heard that term before, especially if you have already taken statistics. In psychology, statistically significant just means is the p-value less than 0.05. And a p-value of less than 0.05, it's in these little dark shaded regions of rejection here where you reject the null hypothesis. So p-value of less than 0.05 means that you would only get the results you found in that particular study 5 in 100 times by chance alone. So that means that you're very unlikely to have gotten those results by chance alone. So it's very unlikely to be a fluke. Instead, it's very likely to be a real effect. So a p 0.05 or less, consider this in contrast to, for example, p equals 0.70, which indicates a 70% likelihood of getting the results by chance, which would be very likely to be just a chance effect and not a real effect. So p less than 0.05, in psychology, we typically think, all right, great, that means it's probably a real effect. So when you're thinking about the question of statistical validity, you can take different kinds of results as an example. So take this graph as an example here. On the x-axis, we have some treatment group and some control group. On the y-axis, we have values of whatever the DV is in the study. If you look at the difference between these 2 bars of your findings, you can see the treatment group is at a value of 25, the control group is at a value of 10. That's a difference of 15 points. So you might ask yourself, well, is that 15-point difference, is that statistically significant? Is it, very unlikely to have occurred by chance? Is it a true effect of the treatment group? Or is it just an effect of random sampling error? So, right, we're dealing with humans, there's always some noise in your data that might affect things, right? You might have some kind of a chance effect just by chance alone, not by any true effect of the treatment group. In this case, a difference of 15 points on whatever the DV is, that's a pretty big difference. It's probably statistically significant, most likely. But you can also, another example, see here we have now the treatment group is still at 25, but in this case the control group now is at 21. So now we have a much smaller difference between these two groups. Now it's only a 4-point difference, right? 21 to 25. So now it gets a little trickier, right? Is this a true difference, or is this 4-point difference? Is that just due to random noise in your participants, not a real effect of the treatment group? The key here is that with a difference like this, you really can't tell whether it's statistically significant just by eyeballing it alone, right? Some people might look at this and say, oh, that's pretty big, it's definitely significant. Some people might say, oh no, it's too small, it's probably just chance, right? And that's why you need statistical tests to tell you whether it's due to chance or not. Here, for example, gets even closer. Now we only have a 2-point difference. How do you know, right? You really just can't tell without the statistical test to tell you whether it's by chance or it's a real effect. Now, in terms of the statistical test that you're using, we're concerned about 2 big types of error with statistical validity. And again, if you've taken stats already, this will probably sound pretty familiar. Even if you haven't, don't worry, this is pretty easy to get the hang of here. With our types of error in statistics, we're worried about type 1 error, which would be incorrectly rejecting a true null hypothesis. In other words, getting a false positive. So a type 1 error, you found an effect, but there really isn't one. So remember, p less than 0.05 or p equals 0.05, for example, still means there's a 5 in 100 chance of getting the results by accident. So it's always possible that you're wrong and it's an accidental false positive. So if you're making a type 1 error here, there really is no effect, but you found one and said that there was. And that's, we don't really want to do that in psychological research. We try to be pretty accurate in whether there's really an effect or not. The other kind of error that we worry about is type 2 error. This type of error is a false negative. So here you're incorrectly retaining a false null hypothesis. So with the type 2 error, you found no effect, but there really is one. So in other words, you don't have enough power to detect an effect that's really there, but your data led you to say, oh no, there's no effect, nothing's going on in this data. So of course, we still don't want to make type 2 errors, because if there really are effects, we want to see them, right? That's the whole point of doing research. We want to find out where there are effects so that can help us, answer our theoretical questions or design interventions, whatnot. So type 2 error you can think of as being maybe not quite so bad as type 1 error, but it's still something that we really want to avoid. So that's part of the purpose of statistical validity, is to assess whether, what the chances are of making one of these 2 kinds of errors. So with statistical validity, you are asking a couple of main questions to assess the validity of your study. You're asking, are the conclusions that you're drawing from the statistics accurate and reasonable, right? You're asking, is p less than 0.05 for these findings? Is there a true effect, or is it just random noise, and claiming there's an effect would be inaccurate because there really isn't one? But you also want to ask, do you have, for example, a large enough sample size and enough power to avoid making errors, type 1 or type 2 errors in your study? So again, you'll talk about this a lot more in stats, but we typically try to have a reasonably large sample size. It doesn't need to be enormous for us to have accurate power, but the smaller your sample size is, the more you run the risk of making a false positive or perhaps even a false negative, right? So if you only have 5 people in each condition, then that's a lot of potential for chance to get in the way. Maybe there's an effect, makes it look like there is an effect, but they're really not. But the larger your sample size is, say if you have 100 people in your 2 conditions, in each of your 2 conditions, right, any possible, random error in your participants should be washed out with that big of a sample size, in which case you should be less likely to make that kind of an error. So statistical validity is really required for saying, okay, do you really have an effect? Or are you making one of those 2 errors that we don't want to make? Now onto the second type of validity that we assess, and that's construct validity. So with construct validity, we're asking, do the results mean what we think they do? So in other words, do the operationalized variables accurately reflect the concepts that we're trying to study? So in other words, how close are your operational definitions to your conceptual definitions of the variables that you are studying? So this, of course, should be pretty familiar. Last week we talked about operationalization as one of the steps of the scientific method. Right? So say if I am studying happiness, right, my conceptual definition of what I'm trying to study is how happy people are, and I might operationalize it as scores on a self-report measure that asks questions like, how happy are you? And participants will rate it, between 1 and 5, very unhappy to very happy. So in this case, the survey people are filling out these questionnaires about how happy they are. That's my operational definition. That's how I operationalize my conceptual definition. And ideally, it should match my conceptual definition pretty well. If it does, then I've got pretty good construct validity. If it doesn't, I might have an issue here. Now, one of the questions construct validity deals with is measuring only the construct you want and not other related constructs. So for example, if you have a test that's designed to measure depression, it should only measure depression. It should only measure that particular construct, not also measuring closely related constructs like anxiety or stress. So the danger here is that the conclusions that you make about depression from your study might really be effects of anxiety or stress instead if your measure is also capturing those constructs. So you want to make sure that your operationalization is, first of all, close to your conceptual definition, so it matches what you're trying to study, and also distinct enough from other related concepts that you're only capturing what you're actually trying to find out more about. So the fact that, we need to have these strict parameters around operationalizations, can be a bit of a trouble for social psychology sometimes because they, of course, need to reflect the construct well, and that can be hard in psychological research. So, for example, one of the things we talked about last week is the fact that aggression is kind of a notorious variable in social psych as being difficult to operationalize well. There are a lot of different ways that aggression has been operationalized in social psych research. And of course, we'll talk more about some of these particular ways it's been operationalized when we get to aggression later on in the course. But right now, I'll just give you kind of a smattering of ways that it's been operationalized in the past. For example, aggression has been operationalized as shocking people. So, telling somebody that there's another participant in the other room and, they have the option of shocking them however, high voltage they want, and the higher voltage you pick should be the more aggressive you're being toward that other person because you're trying to hurt them. All right, that seems, reasonably straightforward. But another really common, paradigm to operationalize aggression in social psych research is adding hot sauce to someone else's food. Now, that might seem really bizarre when you first think about it, but actually the way they set this up is kind of clever. What they do here is they have set up where the participant, thinks that they're interacting with somebody else, and they're told that the other person is about to do a taste test of some kind, and they get the information that they either learn nothing from the other participant about their taste buds or whatever, or they learn from the other participant that they are extremely sensitive to spicy food and it really hurts them to eat spicy food. So the setup here is that the participant thinks that adding hot sauce is going to hurt the other person. Then in whatever way that people are studying aggression, maybe they get supposedly negative feedback from this other participant that makes them mad. Then they have the option to put hot sauce in the other person's food or not. And the amount of hot sauce that they put in the other person's food, if the other person has said, hey, that really hurts to have hot sauce in my food, the more you put in, the more aggressive you're being toward that other person. So it's a little bit of a complicated paradigm, right? And it's an interesting way to study aggression, but you can think of it as being, the more hot sauce you add to this person's food, the more you are apparently trying to hurt them, maybe to get back at something they did to you. So kind of clever, a little bit complicated, debatable whether it's really a good operationalization or not. Now, another common paradigm for aggression in the literature here is the noise blast paradigm. So in this case, it's a little bit of a similar setup to the previous two, where the participant is interacting with somebody else. Usually it's a confederate or nobody, they're just told somebody's in another room. What they do here is they're playing a competitive game where, as soon as a stimulus pops up on their computer screen, they have to hit a particular button. and whoever hits it fastest wins and gets to deliver a noise blast to the other person. So they've got headphones on. They get to choose the loudness and the length of the noise blast they give to the other person. So you think of this as being, if you are not trying to be very aggressive, you might give a very low volume, low duration noise blast, not going to be really irritating to somebody else. But if you really want to hurt their ears, you could give them a very long, very loud noise blast, and it would just really hurt. So you can see this as being another way that you operationalize aggression. And of course, there are also other kinds of physiological measures that you can do as well for aggression. Things like, increased blood pressure, increased heart rate, right? Things like that. All right, so in terms of construct validity, if I do a study looking at aggression and I operationalize it with the shocking people paradigm, if that accurately reflects aggression, then I should get the same findings in another study that uses the blood pressure operationalization if that also accurately reflects aggression. So you should get the same results when you redo the study with other operationalizations if your operationalizations are good. All right. So in terms of evaluating a study for construct validity, you have to ask, first of all, do the operationalizations reflect the construct? Do they make sense? For example, does blood pressure measure aggression, or does blood pressure measure too many other things as well that get in the way and kind of muddy up the results? You also want to ask, do the findings hold up with other operationalizations? So if you repeat the study by operationalizing your variable in a different way, does it still work? So for example, same paradigm with a different measure of aggression, it should still work. If it doesn't, you probably have an issue with one or perhaps both of your operationalizations. All right, the third type of validity you want to look at when you're analyzing or evaluating a study is called internal validity. So this is mainly relevant with true experiments, not so much with observational and correlational studies, because what you're looking at with internal validity is whether the effect you have is due only to the IV, the independent variable, or could it possibly be due to something else? So you want to see, does X have an effect on Y? Is the effect due only to X, only the IV? Was it your manipulation of X that caused the changes in Y? Or is there another plausible alternative explanation for your effects? This, of course, is a really important question to ask when you're evaluating experiments, because the whole purpose of an experiment is to establish causation. So you have to be sure that you really did establish the causation that you think you did, because otherwise, what's the point of doing an experiment, right, if you're not actually doing what you're trying to do? One of the questions you ask is, was there a confounding variable? So remember we talked about this last week. It's a variable that's associated with the IV that produces changes in the DV. Basically, the main point here is that this confounding variable can make it seem like the independent variable caused the change, but really it was the confound that actually caused the change. And this idea of a confounding variable is basically the same thing as a third variable problem from correlational designs, where two variables are related, but only through some third variable. So for example, we talked about the example of murder and ice cream consumption, which is a real-life true correlation that actually does exist, right? But it's not the case that one causes the other, right? Murder doesn't make you crave ice cream or vice versa. The issue is that there's a third variable that explains that relationship of temperature. So we talked about that in terms of a correlational study, right? But confounds can happen in experimental. So you can also recall this example from last week with the SAT test prep experiment. So we talked about how this example of I'm trying to figure out, whether Kaplan or Princeton Review test prep is better. So I manipulate test prep type and I measure change in SAT score. And I find that Princeton Review does way better than Kaplan. Woohoo, significant results. But if I only have women in the Princeton Review group and only men in the Kaplan group, now I've got a confound, because now I don't know whether it's the SAT test prep type that produced that change in score or whether it's a function of gender, because I have a confound of gender. So that means that I can't actually tell which type of test prep is better, because it could be gender that's producing my effects instead. So this calls into question your ability to make causal claims, which again, of course, is the whole point of doing an experiment in the first place. All right, so if you're going to evaluate a study in terms of internal validity, you really need to ask, are there plausible alternative explanations for the findings? So are there variables other than the IV that could have produced those changes in the DV? And I want to note here that sometimes confounds are obvious from the research design. So for example, the test prep example, it's really easy to tell whether you've got a gender imbalance in your conditions, and that's pretty easy to notice. But sometimes confounds are a little more subtle and a little more tricky. So it kind of does require a keen eye of kind of combing through what you actually did in your manipulation and thinking about, okay, well, is there anything I haven't thought about? Are there any confounds that could exist, due to my experimental design that could be influencing my results? So it actually takes quite a bit of effort to kind of, think critically about the research that you've done and probably get other people's opinions too. All right, so when you're evaluating for internal validity, you want to ask a couple of questions in particular. You want to say, all right, does my experiment have random assignment? If it does, my random assignment should help wash out, maybe gender imbalances or age imbalances in your participant samples in your groups. You also want to see, did I control for confounding variables? Are there ones that I didn't take into account that could have affected the findings? And ideally, an experiment should have a blind setup or a double-blind setup. So the best design here is actually double-blind. And that just means, for a double-blind experiment, it means the experimenter who is actually conducting the research or carrying it out, so maybe a research assistant, should be blind to the hypotheses, so they shouldn't know which condition you think is going to have which effect. And the participant also should not know. So that would be just a single blind study, would be the participant doesn't know, double-blind is both. But the issue, of course, is that your participants, if they know what your hypothesis was, then they can, intentionally or not, they can mess with the data, right? We talked about how if the participant likes you, they can maybe, if they can guess what your hypothesis is, they might want to help you out and make it happen. But that's not real behavior, right? It's demand characteristics instead of actual behavior. And on the experimenter side, whoever's actually running the study, actually interacting with participants, should also be blind to the condition, because otherwise you can get experimenter effects, where very subtle bias on the experimenter's part can actually influence the effects of the study. So ideally, neither the experimenter nor the participant should know what the hypothesis is, and that's all to have better internal validity. All right. Last but not least is external validity. So this is just, do your results generalize? So there are a couple of things you want to consider. Do the results you got in this study, do they generalize to other kinds of people beyond just your sample? Do they generalize to other places beyond just where you did your research? And do they generalize to other times beyond the very specific time that you did the research? So for example, say I'm studying the effects of gratitude journaling on happiness, and I find that journaling about the things you're grateful for on a daily basis makes you happier, right? So maybe that's my effect. I've looked at it in terms of statistical construct and internal validity. It all checks out. So journaling about things you're grateful for makes you happier. External validity then is whatever your finding is, does it generalize? So for example, generalize to other people. If I found those gratitude journaling effects with college students, which we talked about last time, most psych studies are done with college students. All right, but do they hold up with older adults? All right, do you get the same findings with a different population of older people? What about with kids? What about with new parents? Right, whatever you want to know, where your findings hold up or don't, you need to be really critical about, all right, I found this with one population, but does it hold up with another? And that would be external validity. Another kind of validity or external validity you care about is whether your findings hold up in cases. So say I found those gratitude journaling results here in Ohio, right? Okay, cool. But do they hold up in Massachusetts? Do they hold up in Montana? Do they hold up in South Korea, right? The study you actually did is here in Ohio. You might think this is being representative of Ohio, maybe of OSU college students in particular, but you probably want to know whether it would apply to other kinds of people as well. So you want to know whether it generalizes to people in other places beyond just the one where you did the study. And you also want to know whether it holds up to different times. So if I found those gratitude journaling results before the 2016 election results came in, do they still hold up afterward, right? Pretty big event in our country, in our history, caused a lot of upset for a lot of people. So, does gratitude journaling still lead to happiness after this big event happened? Or it could be as simple as you did the study in the winter, do the findings hold up in the summer, right? Does the time of the year influence whether it works or not? And, literal time of the, progression of time throughout our lives, would those findings hold up 5 years from now? These are the kind of questions that we're interested in terms of external validity. I want more thing that's important to keep in mind for external validity is this idea of mundane versus psychological realism. So with mundane realism, this is the fact that lab studies might not always look like the real world. So mundane realism refers to how similar an experiment is with real life, right? So how often in your real life do you get invited to sit down at a cubicle, answer personality questionnaires, see a persuasive message, and rate your attitudes toward the topic of the message? Right? That's a thing that you do in experiments. That's not so much a thing that happens in your everyday, day-to-day life. So by necessity, doing experiments in a lab contains some artificiality of the setting, which of course could be, perhaps impacting the way that you respond. You're in a study, maybe you have your own guesses about what's happening, all kinds of things that can influence the mundane realism, right? So with experiments, you always kind of have that downside that it's not very true to real life. But important thing to keep in mind here is this idea of psychological realism. Participants in a lab study done in this kind of artificial setting should still think and act like they do in the real world. So in this case, psychological realism, this is referring to the similarity between psychological processes that are occurring in the lab and in everyday life. So psychological processes are what we're really studying, right? We really want to know how people think, what people do, how they make decisions, whether they're persuaded by messages. Those psychological processes, if that's still what we're tapping into with those more artificial lab studies, then it's probably okay that the setting itself is a little bit artificial. So in social psych, we tend to think that psychological realism is more important than mundane realism because, what we're really studying is those processes. We understand that there's artificiality in the lab setting. It's always important to keep that in mind, but it doesn't, invalidate the fact that you're doing a lab study. It doesn't make those results worthless, because we just want to be sure that the psychological realism is still high. So continuing that persuasion example from the last slide, we may not often come into a cubicle and fill out personality and persuasion questionnaires, but we are often presented with persuasive messages in daily life, right? We see them all the time on TV, on billboards, in status updates on social media, in article shares by our Facebook friends, right? People promoting products in their blogs that they're writing. These things happen all the time, and we are often faced with that choice of, all right, do I buy this? Am I persuaded by this or not? So even though the artificialness of the lab is still present, those psychological processes are what's going on in the real world, and that's what we're really tapping into. All right, so external validity then, if you're evaluating a study on this, you're looking at how well do the findings generalize? How well are they likely to generalize? Are there clear limitations regarding how the sample was chosen, where the study was done, significant effects before or after the study? If so, those need to be taken into account. So in particular, you want to look at whether your study had lifelike conditions, right, to maximize that psychological processes, the psychological realism. Did your study have random selection, as good as you can get it, right? If you can do a reasonably representative sample, then you should. And does the study replicate in other kinds of contexts? So not just the one where you actually literally did the study, but can you get the same findings elsewhere as well? All right, so this is just a little table that summarizes the 4 types of validity with what the name of it is and what it really does. So if you'd like, you can copy this down. Otherwise, it's just a reference for you within the video, within the slides. Oh, excuse me. All right, time for review. So here we go. This is the way that you're going to get your participation, your section points for today. Your section points for today is a 2-parter. So this is your part 1. What you're going to do here is write 1 to 2 paragraphs evaluating our in-class experiment from Friday in terms of construct, internal, and external validity. Right? So not statistical because we didn't collect actual data, so don't worry about that. But evaluate it in terms of construct, internal, and external validity. How did it do? Was it good? Was it bad? What are your thoughts? If you thought a type of validity was low, then come up with at least one suggestion to improve it. So this actually should be pretty similar to the in-class discussion that you had with your peers on Friday. So you can think back to that perhaps. If you need a refresher on what the in-class experiment was, it's in the slides from Friday, so you can feel free to go back and access that and look back through what we actually did. All right, so this is, again, section point part 1. You're going to write 1 to 2 paragraphs about this. You can feel free to pause the video right now while you do this and then you can come back and continue watching when you're done, or you can watch the whole thing, come back to this part when you're ready to write, whatever you want to do. So that's part one. Part two is to decide which of the 4 types of validity is most important and why. So remember, we talked about 4 different types: construct, internal, external, statistical. They all have different goals, right? So your job is to think, okay, which one of these do I think is the most important and why? So you're going to come up with an argument for your validity and an argument against the other 3. And I do want to note here that there is no real right answer to this question. You can have good arguments for any of the 4. Right? So this is just an exercise for you to think about. If you were doing research, which one would you care the most about? Why would the other ones be not as important to you for whatever you're wanting to research? So again, feel free to pause the video while you write this. This can be just, little paragraph format. It can be on the same page as your section point part 1. Actually, I recommend that it is the same page. Right? And remember, for your section point, you're putting your name at the top, you're writing your answers, saving the document, uploading it to the Carmen Dropbox, and that's by 11:59 p.m. on Wednesday, January 18th. All right. So again, there's no right answer to this. Researchers choose what type of validity they want to maximize in any particular study that they're running. And ideally, what we do is build a program of research where different studies maximize different types of validity. So maybe I have one study where I'm really concerned about internal validity. I'm trying to have a really good manipulation without confounding variables, right? So maybe I design my study around those ideas. Right? But of course, if I'm focusing on internal validity, maybe I'm not focusing so much on external. So if I find that the result I was looking for in the first study, maybe in my next study is say, okay, well, I found this with college students, but I really want to know if it happens with non-college educated people as well, in which case I would go take that design and go study that same question with a different population for external validity. So what you really do with this is you choose a type of validity you care about, you maximize it, but you don't just do one study and you're done, right? You do more studies on this topic as well to see what your findings, where they hold up with different kinds of populations, with different operationalizations, etc., etc. All right, so that's evaluation research. The last step of the scientific method then is post-evaluation. It's to revise or replicate your study, your finding. So if you did not get the results you hypothesized, your job is to figure out why. This is the revised part of the method here. You have to analyze your study in terms of, well, do I have confounding variables that got in the way? Are my samples not equivalent across conditions? Do I maybe have a poor operationalization of my DV? Did it not get measured very well? So there are a couple of different questions you can ask about study design, whether your design got in the way, but you also have to be willing to accept the fact that your hypothesis might be wrong, right? And this can be a little bit difficult, especially when you're first starting out in research, when you've done a lot of, literature review to, investigate previous findings on a question you're interested in. You've designed what you think is a really good study. You don't get the findings. But you really think it's true, right, what you hypothesized. So you do need to analyze your design in terms of possible issues that are, preventing you from getting the finding, but you also have to be willing to accept the idea that your hypothesis is wrong, because we are humans, of course, we can be wrong literally all the time. So that's something important to do here, right? And so the revised step here is, perhaps two-parter. You would want to fix any problems that you saw with your study design, maybe a new measure, different kinds of conditions, different manipulation. If you thought those were an issue, fix those and try again. And or reevaluate your hypothesis and be willing to say, well, maybe this isn't really what people are doing, and maybe, it's this other thing is what's happening instead. So you have to be willing to reevaluate, revise your hypothesis, maybe change it, and try again that way as well. But if your results supported your hypothesis, yay, you got significant findings, right? You evaluated the study, it all seems to be good to go. You're also not done, right? You don't do one study, one and done. That's just not how we do research. Instead, your goal then is to replicate your study. So you need to do it again. So if the effect happens again in another study that you run, you can increase your confidence that it really exists. That effect is a true effect, it's real. because you don't want to run the risk of having a false positive, a type 1 error that we talked about before. So with the replication of your studies, you can do this two different ways. You can do an exact replication, which is you literally take the exact same study design that you had before and you just do it again on a new sample of participants. That would be an exact replication, or as close as you can get to being exact. Or you can have a conceptual replication, which is, you're testing the same question again, but you're changing something about the method. So maybe you're using a different operationalization to, improve your construct validity. So a different operationalized variable that should be measuring the same construct. Maybe you're doing it in a different population of people. Maybe you're doing it in a different environment, right? You're changing something about the study so it's not the exact same design, but you're testing the same question. That would be a conceptual replication. Now, any true effect in the world you should be able to replicate, kind of like a pie recipe. So if I make a pie and it turns out great, I should be able to give you the recipe I used. You should be able to make the same pie and have it turn out the same way because I gave you the recipe that I had. That would be like replication of the study. So you should be able to find that result again. But of course, things don't always replicate perfectly. For example, maybe you've seen these Pinterest fails. Somebody tries to make Cookie Monster cupcakes that are super cute and awesome and just totally mess it up. Nailed it. These Pinterest fails are often due to messing up the original recipe. So for example, trying to frost the cupcakes before they've cooled and your icing melts all over the place. But if you follow the recipe correctly, they should replicate. Same idea with psychological research. So if I find that people in a good mood are more likely to help other people, I should be able to repeat that finding and replicate the results. So replication is really important in psychological research. You want to make sure you don't just have a false positive, but that you have a true effect that really exists in the world, and that, for example, you can replicate across different conditions for good external validity. All right. So that's the scientific method. We talked through all 5 steps of it. When and how social psychologists use it, different concerns, right? We talked about the fact that no study method is perfect, no study is perfect. You always have to be very careful to critically evaluate the research you're doing and make sure that it really is good research. All right, so now we're on to the last little bit of research methods, which is looking at ethical concerns with doing research. So all scientists have a responsibility to be ethical and to treat participants fairly. This is just kind of part of how doing research works. You have to make sure that the research you're doing is ethical. You have to make sure that you're treating participants fairly, that you're not putting them in unnecessary, danger or even psychological danger. You have to make sure that you're not harming participants unduly, that you are designing studies that are ethical to conduct. Now, some things we can't do ethically in experiments, or at least not anymore. For example, you might remember Milgram's obedience experiment, which we'll talk about again when we get to social influence later in the course. Right? In this study, they had participants strap in the learner in the experiment, which you can see getting strapped in here to a shocking machine. This was actually a Confederate, but the participant didn't know that. And they had to shock them with increasingly high voltages until they thought that the person was literally dying on the other end to see how far you would obey them, right? That caused a lot of psychological damage, so it's not a very ethical experiment to do. You might also remember Zimbardo's prison experiment, which we'll also talk about again in this class when we get to group processes. In this case, took a bunch of college-age boys and put them in a makeshift prison in the Stanford Psych Department basement. And, some of them were guards, some of them were prisoners, and looked at what happened. And if you remember this from Intro to Psych, it didn't really go very well. Caused, again, a lot of psychological damage. Neither of these studies put actual people in physical danger, but psychological danger is also something we care a lot about in psychological research. Now, one of the reasons those 2 studies cannot be repeated now, even though they were done in the 60s or 70s when they were originally done, is that now we have an institutional review board, or an IRB, whose job is to approve all psychological research studies before they can even be started. So the IRB is something that was constructed partially in response to unethical studies like Milgram and Zimbardo. But now they function to kind of be a check and balance on researchers who are doing psychological research to make sure, whatever, perhaps psychological danger you might be putting people into for your study, to make sure that it's not just ridiculous, that it's very minor, that it's unlikely to cause real harm to your participants, basically to make sure that you're being ethical in your research. So ensuring that procedures are not going to cause unacceptable harm to participants. And literally every study a researcher does has to get approved by the IRB. So if you did REP in Psych 1100 here, whatever studies you were conducting, they were originally reviewed and approved by the IRB before the researcher could do them on participants. Now, part of what the IRB looks for and part of what you have to make sure you have if you want to run research is an informed consent sheet. This is so that every participant who's going to participate in your study is informed of a basic description of the study as well as their rights for participating in the experiment. This is something that the participant gets ahead of time before they complete the study, and that they sign it to indicate that they're giving their informed consent. So a basic description of the study, their rights includes rights like the right to withdraw at any time without losing the reward that they're going to get for participating. So the right to feel like you can withdraw if you're feeling uncomfortable. The right to refuse to answer any questions. So if they're getting asked something that they're like, oh, I'm not comfortable answering this, they don't have to. They can leave it blank. And the right to anonymity or confidentiality. So anonymity is best if you can totally, get rid of identifying information on your participant data. Sometimes that's not possible. Sometimes you need to have their identifying information. For example, perhaps if you're doing a dyadic study with couples, you need to have some identifying information that ties the couple together so that you can analyze the data. But in that case, you would need to have confidentiality so the participant knows that you're not just going to go post their answers to questionnaires on the billboard in the psych building so everybody can read it. Confidentiality would mean you're keeping that data, you're the only one who knows the identifying information. Nobody else is going to have access to that. So again, informed consent, this is prior to beginning the study. Participation needs to be voluntary, and participants should know what they're signing up for before they even begin the research at all. Now, sometimes we can't give all the information about the study, so we have to use deception. So deception involves misleading participants about the true purpose of a study. And we don't do this just for funsies, right? We don't deceive participants just because we think it's funny. We do it because it serves a real purpose. So for example, deception might serve to create situations that simulate the real world so that participants, are not already knowing exactly what we're trying to study, and therefore that's not really how it works in the real world. And probably most importantly, to keep subjects unaware of the manipulation. So we talked a little bit earlier about, possibility for demand characteristics. If people know what you're studying, they can skew your data, whether they mean to or not, right? So for example, if I tell you before the study that I'm assessing whether negative feedback leads to negative emotions, and you know that, and you participate in the study and you get negative feedback, then you know that it's not real feedback, and you know that I'm looking to see if it affects negative emotions. So you could bias the results, whether you mean to or not. So with deception, if you're studying negative feedback, you might tell participants, you still give them an outline of what the study involves, like maybe you tell them the study involves writing a short essay about your adjustment to college, submitting it to your partner in the other room who's going to evaluate it and give you feedback, right? So they know that's what they're going to do, but you don't tell them exactly what you're studying, so that when they get this negative feedback from their ostensible partner, they think it's real and they react in a realistic way. Because we don't want to know what people do when they already know what we're studying. We want to know what they actually do in the real world. We want those psychological processes. So that's what the purpose of deception is. It's to make sure that you're studying what you want to be studying, and not that you're not just studying demand characteristics instead. But I do want to point out deception, you have to keep it as minimal as possible when you're doing research, and this also gets passed by the IRB. So the IRB looks at what your deception is, what the purpose is, and makes sure that it's not causing, that it's not a big problem, that you're not telling participants something just utterly ridiculous and then they're, exposed to risk by not knowing what's really happening in a study. So the IRB approves your use of deception as well. All right. After the study, you also have to have a debriefing, which is where you explain to participants what the true purpose of the study was. So, deception, you might not tell them the true purpose right away, you might mislead them a little bit, but before they leave the lab or before they X out of their online browser for doing an online study, you debrief them so that they do know what the true purpose really was. So they should not leave the study without knowing what you were actually studying. They just might not get that information in all until the end. So the purpose of a debriefing is to explain what deception was used and why it was used. So again, to prevent demand characteristics or whatnot. And it's also to alleviate stress. So if I led you to think that the negative feedback you got from your partner was real, because I want to study what your emotions really are after getting negative feedback, then it's my responsibility toward you to take pains during debriefing so that you know that feedback was not real. Right? So if you get negative feedback from your partner, maybe you're really upset, you're angry, you're irritated, maybe you're even having a little dip in your self-esteem because you thought you did well, but your partner didn't. I need to make sure that I tell you, hey, that wasn't real feedback. Nobody actually read and evaluated your essay, so you don't need to feel bad about getting this negative feedback that wasn't really actually from anyone in particular. So alleviate any stress that might be caused by the manipulation, by whatever you're studying, by the deception. So your participant needs to leave the room, needs to leave the lab, not in any worse shape than they came into it. So whatever, psychological harm you might be causing them should only be minimal, of course, but you also have to alleviate it before they leave. All right. So that's our recap for today. That's our research methods lecture. So recapping all of research methods, right? We've talked about observational, correlational, experimental methods. They all have strengths and weaknesses, but experiments are the only type of study method design that allows for causal conclusions. And that's why throughout this course, you're going to see a lot of examples of experimental research. Fewer examples of correlational and observational research. We still do them in social psych, but experimental research tends to be kind of the bread and butter. That's what we really are looking at to figure out why things happen, what causes what. You also have to, of course, evaluate the reliability and the validity of any given study that you've done, revise and replicate. Of course, research is crucial to the social sciences. So social psych is really built on the scientific method, on research that you're conducting. That's how we know things about the world. You can recall, we talked in the first day of research methods about how intuition or, common wisdom is maybe not as clear cut as it may seem to be. That's why we need research to actually find out what's really happening in the real world. So why this is important? Because there's no such thing as a perfect study. So hopefully what we've talked about today with evaluating and replicating your research has, gone a bit further to show you that there is no perfect study, but of course people instead build programs of research that involve different kinds of studies that should add up to a pretty good understanding of a subject or of some whatever given question you have. But each study alone is subject to having faults and weaknesses. And of course, even though there is no perfect study, science is the best access to truth that we have. We just have to be careful with our interpretation of it. So I do want to leave you with a note of the fact that you should never blindly assume that researchers have conducted perfect studies, because it's not necessarily the case. And a lot of the studies that do get conducted might have major implications for your life and for your happiness. And that, of course, applies outside of social psych as well, perhaps even more relevant outside of social psych. If you think about, studies that are testing the effectiveness of prescription drugs of any kind, if those studies are funded by the pharmaceutical company that produces the drug, now you've got a conflict of interest. They're saying the drug is great. Is it really great? Or do they have experimenter effects, right? So there is no such thing as a perfect study, and you should always critically evaluate claims that you see in the media, reporting results of findings and conclusions. Even within social psych, conclusions that people make might be outrageous. For example, you might see lots of studies where people will report on a correlational study and use causation language, and hopefully now you're aware of the fact that a correlational design does not let you do that because of a third variable problem. And you can be a little bit more, informed when you're looking at these claims that are affecting your actual daily life. So before we wrap up, I want to give you one more example of why this. So this is a true example. Previous research found that babies younger than 2 years old who slept with a nightlight on were at increased risk of developing nearsightedness in childhood. Nearsightedness, of course, needing glasses because your vision's not 20/20. So everybody thought, oh no, everybody needs to turn off their nightlight so that their babies don't get nearsighted, right? So this simple fix should make sure that my baby has 20/20 vision. But in fact, no, that's not the real thing that's happening in the real world. There's actually a third variable at play that is causing this to seem like a relationship that's causal, but it's really not. And that third variable is that the parents of these babies were nearsighted. So nearsighted parents were more likely to use night lights at night, and the kids were more likely to develop nearsightedness due to genetics. But just those two variables measured alone of use of night lights and baby nearsightedness looks like a causal relationship, but really it's only correlational, right? So this kind of a causal claim that's affecting, might affect what you're doing when you're, raising your kids or making decisions about your life. And you have to be able to analyze whether that's really a true causal effect or not. I've included a couple of links here to websites if you're interested in this topic and you want to know more about, different kinds of correlations, spurious correlations they're often called, if there's a third variable involved or they are just really bizarre. So you can check out some of these links if you're interested in seeing some actual real-life true correlations that are most likely not actually causally related. So feel free to check those out if you would like to. And last but not least, just want to leave you with this idea that you know better now, that correlation does not imply causation, but a lot of people don't. It's not necessarily their fault, right? If other people have not taken statistics classes or psychology classes, they just might not know that correlation is not necessarily reflective of a causal relationship. And that's why correlation and observational findings often get reported in the media in causal language. So you have the tools now to analyze that, so you should definitely use those tools. All right, so quick reminder, again, Friday we're not going to have class. Also, I'm still out of town. You can use that time to work on your article critique, so don't come to class unless you want to. Nobody's going to be there. You can access those articles on the module on Carmen. The assignment prompt is on Carmen as well, as is the Dropbox. So 11:59 p.m. on Friday is your deadline for turning in your article critique. I would say make sure you take a look at the rubric. That's literally what I'm going to use to grade you. Make sure that you're addressing all of the questions in the prompt. No specific special formatting for that. Just make sure your name is on the assignment, you submit it by the deadline, and that you've answered all the questions on the prompt. I would say I prefer paragraph format for that, but I'm probably not really going to mark you down if you do bullet points instead. If you have questions, you can feel free to email me. I will be a little slow to respond, but I will probably still respond within 24 hours. So you can feel free to email if you have questions. Otherwise, I hope you have a great rest of your week, and I will see you next week.